Now that my hair is dry, I want to explain to you a physics concept called Bernoulli's principle. I've always been fascinated with aerodynamics and how moving air can cause forces like lift and downforce. This interest is personal to me because my grandpa was a race car driver, and learning how physics can affect speed, control, and especially safety on the track always interests me from a young age. Let's start by looking at a picture of an airplane wing. As you can see, the arrows over the top and bottom represent airflow. Because of the curvature of the wing, the airflow over the top is accelerated, which means that it moves faster than the air underneath. According to Bernoulli's principle, when air velocity, or speed, increases, the pressure decreases. So the faster moving air on the top creates a lower pressure, while the slower moving air on the bottom creates a higher pressure. And this difference creates lift, represented by the green arrows. So now, let's take a look at the equation behind all this. Bernoulli's equation. According to Bernoulli's equation, P, which represents pressure, plus 1/2 rho, the density of a fluid, in this case air, times velocity squared, which remember, velocity equals speed, equals a constant. So there are two terms on the left side of this equation. And if one were to increase, the other must decrease in order for the equation to remain constant. So if velocity increases, then the pressure must decrease. And if velocity decreases, the pressure must increase. Now that you understand Bernoulli's principle a little bit better, let me show you what you saw in the beginning. Even though most people expect the fast-moving air to blow the ball away, the ball stays suspended. This is because the fast-moving air creates a lower pressure, while the surrounding slower air creates a higher pressure, keeping the ball suspended above the hairdryer. This is even why I can tilt the hairdryer at almost a 45-degree angle and the ball stays suspended, because of the differences of those pressures. Now, if we take this airplane wing and flip it upside down, we get the same physics, but instead of a lift, we get a downward force, or a downforce. Race cars are designed so that fast-moving air goes beneath the car, creating a lower pressure, while the slower-moving air goes above the car, creating a higher pressure, which is that downforce. That downforce pushes the car into the track, increasing traction, which allows the car to make fast turns at extremely high speeds, reaching upwards of 150 miles per hour. Now that's Bernoulli's principle for you.